On to word problems. Your favorite. Words, words, words. Equation with lots of variables. Maximum power. There we go. Maximum power. So there's our power function. E and R are fixed. If they're fixed, they're numbers. So let's put numbers in it first, just to get a better handle on it. The capital R is then the variable. Well, let me just graph it. I don't really need the 3 squared, so I'll just graph on that. Plug it into my calculator. Oh, there's the function. Looks like there's a maximum there. I don't know what's happening on the left side of the screen. Let's see what x values I'm looking at. There's 0. Oh, there's negative numbers. I don't care about negatives. Resistance can only be positive. So yeah, I should be able to find that one maximum. Alright, off we go then. Map out my function. Multiply by 3 squared. Multiply by 1, add 2. Square. So there's our chain. And then I'll divide. And there's my function. Everything's elementary. Well, before we start getting too excited, let's replace the numbers with the letters. So 3 was really E, 2 was really little r. Replace, replace, replace. Okay. Now, everything's elementary, and let's get rid of the little crutch we had and put in our derivatives. The constant function e squared, constant function 1, chain rule, multiply the derivatives, quotient rule, calculate the derivative. So I'll differentiate the p function and quotient rule. Derivative of the numerator times the denominator minus numerator derivative of the denominator. A 2 times function with input capital R plus little r times 1. Divide by denominator squared. Clean it up, and by clean it up, I mean factor. Factor, factor, factor. Capital R appears many more times than once, so we're not going to be able to explicitly solve. So it's going to have to be factored form equals 0. So factor, factor, factor. Combine like terms. Sweet. Now we're ready for getting the critical point. Set the derivative equal to 0. It's in factored form, so the only way you get 0 is at least one of those terms has to be 0. So either e squared is 0, or capital R plus little r is 0, or little r minus r is 0, or the denominator term is 0. Well, e squared's not 0. Resistance can't be negative, so nope, that's not allowed. Oh, there we go, that works. And no, reciprocals can't be 0. So we have one critical point, which matches what we saw in our little graph when we just kind of tried to see what it looked like. So now we're going to test that critical point. I'm not going to compute p double prime because it's just too many terms. I only have one critical point, so I just got to find the sign on either side. Since it's all multiplied out, it's easy. I can just look at the sign of each term. All of them are positive except for that one. So I plug in something to the left. I get a positive r over 2. I plug in something to the right. I get a negative r over 2. So my p has a positive slope and a negative slope. So it looks like a upward line, flat, downward line. Well, that's a maximum shape. So our maximums at when the external and internal resistances match. Now we got to answer our question for the maximum power. So our maximum power, when I plug it in, E squared R over R plus R squared. And then just compute. So our maximum power is at R equals little r, and it is E squared over 4 little r watts, when capital R is the same resistance as the internal resistance.